Albright with AVNation at ISE 2018 in the HDBaseT Alliance booth with Daniel Schwartzberg. How are you, sir?
I'm doing very well, Tim. How are you doing?
Good. Good. You guys have got some exciting things going on. A chip that you are in development right now.
That's right.
That helps folks who are doing HDBaseT switch within the chip.
You got it.
Explain kind of what's going on there.
So the theme of ISE 2018 is Unleash the HDBaseT Network.
Okay.
And before I get to the chip, we're talking about a network on several different levels. First of all, we're talking about a network of member companies of the Alliance who are producing HDBaseT products. And yesterday we announced that we've now crossed the 200 member milestone. We have 21 of those members in the booth this year. It's our biggest booth ever, showcasing the product. So we've got this huge network of members, making an even huger network of HDBaseT products. We've got thousands and thousands of approved and certified HDBaseT products that can all interoperate with each other to create an enormous ecosystem of HDBaseT technology. Beyond that, we have our installers. We have more than 10,000 registered installers on the HDBaseT installer zone.
And these are people who have gone through your training to become certified.
We've got something like 6,000 of that 10,000 have been through the training, so we have all of those installers out there authorized to install HDBaseT. We even have more than 130 authorized trainers that they can go out and train other installers to do HDBaseT. So we have a huge network at the people level, at the company level, at the product level, and then we have this, and this is the new chip from Valence. It's literally hot out of the oven. It's just arrived, which is a switch network at the HDBaseT level. Enables us to switch HDBaseT packets from inputs to outputs at the HDBaseT level, giving us some very, very powerful capabilities, like the example to switch with HDCP.
Okay.
Other switch matrices today, what do? They terminate the HDBaseT, they get all of the native interfaces like the HDMI and the infrared and so on and so forth. They switch those at the native level, and then they regenerate HDBaseT outputs from those native interfaces. That means that the switch matrix is fairly costly in terms of the components in there, the size of the boards. There's a lot of technology on that board.
Real quickly, and to explain why, because what they're doing is they're taking the HDMI and they're converting that. They're taking the IR and they're converting that. What you're saying is convert it to HDBaseT and let us switch it.
Absolutely. So leave it at the HDBaseT level.
On the chip. You're switching it on the chip.
On the chip. That means that I don't need to put in expensive crossbars, which is used to switch the TMDS signal of HDMI. I don't need to put in very expensive FPGAs, which are needed to switch everything else. And whatever data type has been input into the HDBaseT switch, it can be switched. So I mean, I can switch HDMI, of course, but I can switch USB. I don't know any other technology that can do that. True switching of USB. I can take multiple HDMI streams. I can combine them through the HDBaseT switch into a single HDBaseT output. I can do the opposite. I can take a single HDBaseT input that maybe has HDMI and maybe has I2S audio, and I can output those two elements at completely different points in the network. So it gives us the capabilities to create brand new topologies with new capabilities and new features that until now have either been impossible or the implementation has been very complex and therefore expensive for the vendors, which feeds back into a price point of the products that is maybe quite expensive also for the end user, for the installer.
The one neat thing about your stand usually, and the good thing and the bad thing, right? You guys are the technology.
Yes, we are.
Right? You don't sell you don't sell switchers.
That's right.
So this chip you're talking about, you're trying to get into manufacturers' hands, and then they'll eventually make the switchers with this chip. It will lower the cost, hopefully lower the overall heat because you have fewer chips, which also will lower the cost of the power supplies and the heating and the cooling elements, right? So what we're looking at today is kind of future casting.
Absolutely.
Right? Since that's the case, where are we looking at as far as development time so you guys get this in the hands of manufacturers?
So that's an excellent question. Right at this point in time, I would say it's a tiny bit too early to say that the silicon has only just arrived. What we have running behind here in the demo is first generation of firmware, and it's only not even engineering sample ready. We're probably going to need, I would imagine, probably 2 to 3 quarters in order to start getting this through. I would love to see this chip in the hands of our customers definitely before the end of 2018. We think that this is a game changer in terms of what it enables them to do from a feature level and in terms of the industry, and you summed it up beautifully right then. Cheaper power supplies, less heat dissipation, simpler board design, smaller products, less cost involved in manufacturing, which hopefully should feed through to less cost involved for the guys who are buying this equipment. So this is a very important building block to get more HDBaseT products out there, and not just in terms of the number of products, but also the types of products. This enables us to create new topologies. We can create some wonderful solutions, for example, combining HDBaseT networking with an eventual HDBaseT IP solution. When that will hit the market, we can begin to create hybrid networks, islands of HDBaseT that can be connected through an HDBaseT IP solution if we need to go beyond that sort of in-building range that we would have with an IP.
Which actually helps you leverage an existing HDBaseT network when you're moving towards IP.
You got it, you got it. So we're not talking about replacing anything. What we're saying is keep what you've got, create hybrid installations, build upon what you have on this chip, and the capabilities that it carries very much enables us to do that. So, like I say, unfortunately, I'm not involved in the development aspect here. I'm not involved in the timelines. I really would like to see this out there as quickly as possible in order to satisfy what we believe is a very important need in the industry, in the market, for more functionality at a lower price point.
All right, very good. If an integrator wants to become certified or learn more, or a manufacturer wants to learn more about this chip or the other chips, how do they do that?
Well, first of all, of course, if they're here this week and they see it this week, they should come here. They can, of course, reach out to the HDBaseT Alliance, www.hdbaset.org. We have links to all the people there who they can speak to. The chipset is actually developed by Valence, www.valence.com. They'll be able to find more information there, and again, lists of contacts and a way to reach out to us. So I would start probably through those channels. We'll be in Infocom in June in Las Vegas this year, right? Sunny Las Vegas, where we will be showcasing this as well. There'll be another opportunity if people want to speak face-to-face with us about it. But definitely reach out for vendors, reach out to the local sales guys at Valence. We'll be able to provide them with more information.
Very good. Daniel from HDBaseT. My name is Tim Albright. For more information about us, you can find us at AVNation.tv and AVNation.tv.